All right, let's jump right in. We're about to explore one of the most exciting, maybe one of the most important frontiers in all of AI. We're talking about the quest to give artificial intelligence something like common sense by building what are called world models. Seriously, this is the tech that could completely change how AI understands and interacts with, well, our world.
To really wrap your head around this, let's start with a kind of wild question. What if an AI could dream? And I don't mean about electric sheep. I mean dreaming about our physical world, simulating it inside its own mind, running little what-if scenarios, and predicting what's going to happen next. That feeling, that idea, that's the absolute core of what a world model is.
So, what is a world model, really? Well, you can think of it as an AI's internal simulator of reality. Instead of just reacting to data it sees, an AI with a world model can actually build a mental map of its environment, and it uses that map to predict the future. It's the huge difference between an AI that can just recognize a picture of a cat and one that understands that if you push a glass off a table, it's going to fall and shatter.
And this highlights a really fundamental shift in thinking. Traditional AI, like the large language models we all use, is incredible at learning from just massive amounts of past data. But world model AI, it's taking the next leap. It uses all that learning to build a framework for predicting what comes next. It's a move from just passively recognizing things to actively simulating them. So here's the roadmap for our journey today. First, we'll dive into the AI's inner world. Then we'll look at the incredible inspiration for all this, our own brain. We're going to cover the two competing visions for how to build these things, see them in action right now, and finally, we'll look at the incredible promise and the potential peril of what's coming. Okay, so let's start with the AI's inner world. This is where we go way beyond simple pattern matching. Like an LLM just predicting the next word in a sentence. We're talking about stepping into the realm of simulating cause and effect, essentially giving the AI an intuitive grasp of physics. Now, what's really fascinating here is that this idea isn't new at all. Way back in the 1960s, you had projects like Shredlu trying to reason about a simple world made of blocks, but the tech just wasn't there. It wasn't until around 2018 that we got the tools to actually learn this stuff from raw pixels. And today, that has just exploded into these huge generative simulators like OpenAI's Sora. And looking just ahead, we're already seeing a totally new wave of abstract models like Meta's JEPA, which are, believe me, changing the game all over again. Okay, so let's shift gears and look at how all of this is built on the most powerful prediction machine we know of, the human brain. The people building these AI systems are literally taking their blueprints directly from cognitive science. Our brains are constantly, and I mean constantly, running simulations. Just think about a professional athlete for a second. They can react to a fastball or a tennis serve almost instantly. In fact, it's faster than the nerve signals can physically travel from their eyes to their brain and then out to their muscles. So how is that possible? It's because their brain isn't just reacting. It's using this highly trained internal world model to predict the ball's path before it even gets there. This whole process is called predictive coding, and it is remarkably efficient. Let's just walk through it. First, your brain is pumping out a constant stream of predictions about what's about to happen. Then, your senses bring in feedback from the real world. Now, here's the brilliant part. Your brain doesn't waste energy processing everything it got right. It only focuses on the surprises, that gap between what it thought would happen and what actually happened. And then it uses that error to update and refine its internal model. That right there is how we learn. Okay, so this brings us to a huge debate happening in the AI community right now. There are basically two competing philosophies for how we should be building these world models. You can think of it as a high-stakes race between two camps, the photorealists and the abstractionists. So on one side, you have the generative approach. Think OpenAI's Sora. The goal here is to simulate a completely pixel-perfect, photorealistic world. The big challenge? It's just computationally massive, and it often has a really hard time keeping the laws of physics consistent. Then on the other side, you have the predictive approach, championed by models like Meta's JEPA. The goal here isn't to create beautiful videos, it's to predict abstract concepts and cause and effect. The challenge for them is learning all those complex interactions without getting lost in every single visual detail. AI pioneer Yann LeCun, who is a huge champion of this abstractionist approach, puts it perfectly. He basically argues that trying to predict every single tiny detail in the world, like the exact way a leaf is going to flutter in the wind, is a total waste of computing power. He says the AI should focus only on what's important and what's actually predictable, the underlying physics and the relationships between things. But look, this isn't just a theory anymore. This technology is already being used out in the real world. So let's check out some incredible examples of world models in action right now, from the cars on our streets all the way down to the cells in our bodies. Probably the most visible application is in self-driving cars. We're seeing this shift to what some people are calling AV 2.0. So instead of just relying on these super rigid, pre-built HD maps, companies like Wave are now building cars that have a world model. It acts like a mind's eye, letting the AI simulate and anticipate traffic, pedestrians, and all the unexpected stuff that happens on the road, all in real time. And in robotics, the gains in efficiency are just wow. There's a new approach that lets the AI plan its next move directly inside its internal simulation, without having to generate a full video of its thoughts. This makes the whole process so much more efficient, cutting the computational needs by a massive 75%. That means faster, more intuitive robots. And the scale of this tech is just mind-blowing. In science, a project called ElmerFold used an approach inspired by world models to predict the 3D structure of over 41 million proteins. That is a monumental leap forward, and it's dramatically speeding up the discovery of new medicines and treatments. The applications are just incredibly broad. We've talked about driving with Wave's Gaia and robotics with VJEPA 2, but this same tech is being used in climate science to predict extreme weather events, and even in biology, where projects are creating fully simulated 4D digital cells to understand life at its most fundamental level. Okay, let's get to our final section and look to the future. Because the development of world models is, without a doubt, a huge step towards artificial general intelligence. But it also comes with some fierce global competition and some very, very real risks. One of the biggest risks is something called a physical hallucination. This happens when a model creates a video that looks totally real, but just completely violates the laws of physics. The source material has a perfect example. A language model might say an elephant could fit in a sedan, just because those words sometimes appear near each other online. But a flawed world model might actually show it happening, with the car stretching like a cartoon. Now, in a self-driving car, a mistake like that, well, it could be catastrophic. And believe me, the race to perfect this technology is on fire right now. Jan LeCun's new company, AMI Labs, just raised over $100 million to build AI based on physical common sense. Meanwhile, China is all in on an embodied strategy, actually embedding AI into real-world city infrastructure. And then you have companies like DeepSeek building these incredibly efficient models that can compete with the best in the world, but at a tiny fraction of the cost. But as everyone races forward, it's so important to remember the major hurdles still ahead. We have to guarantee physical consistency. We have to figure out these impossible ethical dilemmas, like the classic trolley problem for self-driving cars. We have to solve these huge legal battles over data and copyright. And we have to create strong safety rules to stop this tech from being used to create hyper-realistic, dangerous deepfakes. All of which leaves us with one final, and I think pretty profound question. As we push towards ever more advanced AI, we have to ask ourselves, to achieve an intelligence that we would actually recognize as general, as truly adaptable, does an AI first have to learn how to simulate, how to predict, how to essentially dream our physical world? That is the billion-dollar question that's driving this entire revolution.